Hello everybody, my name is Tomáš Vojnar and I would like to tell you a few words about static analysis and the research planned on it in the Values project. Myself, I'm from the Verifit group of the Brno University of Technology, in particular the Faculty of Information Technology. Our group works a lot on both static analysis as well as dynamic analysis. We conduct research in these fields as well as we try to apply these approaches in practice in collaboration with strong companies such as Red Hat, Honeywell and others. In this micro talk, however, I would like to concentrate on static analysis. So, very briefly, what's static analysis? It's a kind of approach to analyzing or verifying code without actually executing it, or for sure static analysis tries to avoid executing the code under its original semantics. It comes with a number of advantages, like it can be applied at early implementation phases, even on fragments of unfinished code. It can thus discover bugs early, and then they are easier to correct, hopefully, since first, developers have a fresh image of the code in their minds and they can more easily make changes in there. And also the consequences of such bugs hopefully did not propagate too far in the project, and so the needed changes should not be that big. Static analysis can find even rarely manifesting bugs, such as bugs in concurrent code, which can appear maybe once in several thousand million runs. The code seems to be running well and suddenly it completely crashes. And similar kinds of bugs related to memory safety, occasional non-termination, which you probably all know, some tool which seems to work most of the time suddenly starts hanging. Finally, to mention one more advantage of static analysis, it may not only show presence of bugs, but sometimes also prove absence of bugs, which can be convenient, for example, when certifying some critical software. A little bit, but a tiny little bit about principles of static analysis. As I have said, it's trying to analyze code without running it. So what it does instead? Well, it can do various things, ranging from purely syntactic analysis based on pattern matching. So for those of you who know grep, you can view grep as a static analyzer. So it's basically really pattern matching in text. But one can also work with more heavy symbolic or abstract execution based approaches, which in fact do execute the code, but not under the original semantics, but somehow abstract semantics. The different approaches can be concretized to many different and heavily studied forms of static analysis, like error patterns, data flow analysis, abstract interpretation, symbolic execution, extended type systems, etc. Clearly, I don't have the time to go into details here. Let me get back once more to the advantages of static analysis, which I have already mentioned, and then mention also the dark side. As I have said, static analysis can, or at least some analysis can handle very large code bases, meaning millions or even billions of lines of code. They can be applied early in code development, sometimes can not only find bugs but also guarantee absence of bugs, can find rarely manifesting bugs, and support for static analysis in the form of various tools ranging from very costly commercial software to open source, both commercial as well as academic implementations. The tools are applicable to many different languages, kinds of bugs. As for the dark side, as for the disadvantages, sometimes static analyzers can report lots of false alarms, and then the developers have problems to distinguish what's a real error and what not. Some analyses do not scale enough, so I have said yes. So some analyses can scale to billions of lines of code, others may have problems with hundreds of lines of code. And Well, I have said that many programming languages, classes of bugs are supported, but not all. Some program features may be difficult for static analyzers. Some classes of bugs may be completely not supported or less supported, or one needs to fine-tune the analysis for the concrete kind of code which is used in some company. What are the goals with static analysis in values? How do we want to improve it? So our aim is to improve precision, scalability, and or generality, meaning support of more features, more bugs of selected static analysis. In particular, we aim at improving and developing new interprocedural static performance analysis, so looking for performance-related bugs like accidentally quadratic code and so on, which can easily make some code hang for some inputs. New scalable analysis aiming at concurrency defects, even for less studied synchronization means, such as read copyability used in low-level systems code. And then we also want to tackle static analysis for low-level memory manipulation, developing new analysis for code fragments that use pointer arithmetic, address alignment, recursive data structures, block operations, and the like. We want to implement our static analysis either as standalone tools or plugins of environments, open source, strong environments such as Facebook Infer or Pharmacy. That's all from me in this super short talk. Thank you for your attention.